Welcome back, coders. My name is Daniel, and in this video I'm going to show you what I've been up to for the last year. Okay, while I get all of this set up here, I'm going to tell you, over the last year, I've been working on a platform to simplify microservice development. And what I wanted to do is, well, let me tell you why I started this. Sometimes in the day-to-day, hustle, the day-to-day work, you might get too focused on what's in front of you and you might lose the bigger picture. I wanted to try what's possible with the technologies that are currently out there, and I wanted to focus on three pillars: productivity, developer joy, because this is a side project, I don't want to be miserable, and ease of testing. I want to be in control of every aspect of the testing. And you see, web services are have tried and true recipes that you can follow. Those are patterns that can be distilled into code. And if you can distill the essence of what service does, you can also distill the essence of the tests. And if there's any overlap with any other microservice that might be the same, then you can reuse that part, right? That's the basic tenet of modularity. The other thing is, you can have the greatest software in the world, but it's by definition useless if you have no users. So I was thinking, okay, what do I need to get users? Well, you need to deliver your software to have users. And what do I need to do to deliver the software? You need infrastructure. So what I started with was a very basic Terraform project, just to set the stage for what I was going to use next. So I want to show you now what I've been doing and how it works a little bit, and maybe you can get some inspiration from it. Okay, so what you see here is a basic diagram of what the architecture looks like. The important parts are just 4 modules. In fact, just 3, but I'm gonna explain them as I go along. All right, so first you have the core of the project. I named this project Isekai because this is like another way of doing things. And Isekai, if you're familiar with manga, it means another world, basically. I wanted this to be another world, different from what I'm doing in my day-to-day. So this is my side project. You have the core, and in the core, I'm defining the spec, basically. How the shape of the objects look like, what are the contracts that you need to follow, what are the any testing you want to do, it might be there. And I follow the same philosophy for all of the projects. Basically, you produce 4 artifacts from each project. And the idea is that you have the main artifact, but you also produce the sources for that main artifact to make one of the pillars, developer joy, to fulfill it and make the development experience better. So you go into your IDE, you have the sources, you can see what's inside. It's easy for you to figure out how to orient yourself inside when you're using this module. The other thing is, I'm also producing test artifacts. Those are things that you're going to be depending on in your project to aid with your testing of this particular part. And obviously, the sources for the tests are also available. So those are the 4: code, sources, tests, and the sources for the tests. After you get the core, the basic spec complete, then you have two things that I always use. Mainly persistence. So 90% of the microservices out there use persistence. And also the interface to receive requests. Those are then the Isekai JPA for persistence and the Isekai web to receive requests. The fourth optional project is the Isekai JPA Eclipse link. That's just in case you want to use Eclipse link. I have utilities inside to make it easier to use Eclipse link. In the end, I don't want to get married to any technology, right? So I'm using standard technologies, and I'm not using any proprietary annotations or anything like that. And once we get to the infrastructure and how to deploy it, I'm going to show you that it's very easy to change from one technology to the other without having to change your microservice, the essence that you distilled yourself. The idea is, that's why you see, for example, Azure SQL configuration, Oracle configuration. You can choose at compile time which database you want to use for testing, and it'll automatically choose the driver, start your Docker container, test against that Docker container, and shut everything down. Alright, I'm going to show you some code now. Okay, so before I show you code, I'm going to show you what we're going to end up with. If you see the screen, you're going to see a basic HTTP response. This is a REST response from the service, and maybe if we look at the network and we try it again. Alright, so if you look at the right, you can see it took 99 milliseconds, and I just started the Kubernetes cluster. The idea is that I can do this on my own. I don't have to pay for any infrastructure because I can tear everything down. Once I start developing, I just build all the infrastructure I need, do my development, test it, deploy it, test it again. Once I'm done, I can completely tear everything down and not have to pay for the infrastructure that I'm not using while I'm not developing. So this is, I'm thinking as an enterprise, right? I want to have enterprise grade microservices, but I'm just one developer. I don't want to have this infrastructure up all the time, consumed, because I don't have any users yet, right? So I was building this in a way that allows me to be productive, but also efficient. I don't have to spend while I'm not developing, I'm not serving users. This was just for having all the modules work together, and also it serves as reliability engineering a little bit. So if anything happens, I can just tear everything down, build it back up, and everything is running again. So having those scripts and the ability to tear everything down and build it whenever I want gives me confidence about my infrastructure and security. If anything, disaster recovery is needed. If any disaster recovery is needed, I can do the same thing I'm doing when I'm developing, right? So as I said, 99 milliseconds. I just started this cluster, so you're gonna see numbers. Now it's starting to get better, and this is due to caching. If nothing is changing with the data, you shouldn't need to fetch it all the time from the database. So this has two layers of caching. One is the second level cache from the persistence layer, and another one is the front end cache from the web module. Alright, so the shape of our object is very simple, has 4 columns, and that's it. This represents roughly what a locale would would be in the Java world. This one receives only one. I'm just looking for one of them, but I can easily fetch all of them, and now you can see this is an array. Right now my database only has one. I have a few other endpoints that I can show, and if you look at this, then you can see that this response is a little bit different. So now you can see you get a count because I'm searching for pages, and if I'm gonna show you the way the different queries work once you're there, and if you're interested, I'm gonna perhaps also show you how all of this is deployed. You see the images I have. So this image I have is 60 megs. That's the whole application. And the way I package it is I build it as a native application. So this is deployed on a container that has very little inside. So there's nothing inside except my application. There's no image for any Linux distribution. There's nothing except my application. This is everything that is inside that image. It's just copy my application, expose a port, and run my application. That's it. I don't have dependencies. This is all built statically. I don't have any external dependencies. I don't depend on libraries from any Linux distribution, C. I don't depend on Java. This doesn't depend on Java. That's why the image is so small. The other thing I can show you is this image I pulled from the container registry. So I can test locally in the same way I deploy in the cloud. In this case, I'm gonna maybe start this database, and once this database starts, I'm gonna start the application. So, all right, start it up. I'm gonna go back and check this. I'm gonna start my application, and let me clean this. And once I start the application, you're gonna see, all right, this started in 452 milliseconds. Usually in the cloud, this starts in less than 200 milliseconds. And this is already serving requests. I'm gonna probably have to show you how to look for one of those requests. Let's see. All right, so let me do this. I'm going to put this side by side with the other one, like this, yeah, and I'm gonna put this one here. Okay, so I made a few requests, made 3 actually. This one uses pagination. If you see, you can see the page 1, limit 100, that's this. If you look for a single entity, a single record in your database, this one is cached, so it didn't do a query. I'm using Hibernate for this, but you can easily switch it to use whatever JPA vendor you want. And if you want to find all of them, then you can do this, right? I have caching on because otherwise you wouldn't see anything. And that's why it takes 30 milliseconds. That's network latency, database access, etc. I'm going to show you again if I run this once. Okay, so this is the one with pagination. If I do just a single one, that's this. If I search for all of them, then that's this. So you see, if you do all of them, I just search. If I start doing the single one again, it doesn't go to the database. Right, so okay, so now we're going to see the logs in one of the pods. I don't know which one. Let's check this one perhaps. This one. This one has a bunch of requests, so this is not the one we want. Let's look at this one, probably. Let's see if this works. Alright, yeah. So this is probably the one that we want. I'm gonna run, see the logs. Okay, this one started in 110 milliseconds, and I want to do this one. All right, so this is development. So what I need to do is switch this one to dev, and this one responded in 160 milliseconds. So yeah, 31, 32, there you go. This one got hit, and this is selecting a single one by the ID. This is the first time. So the first time, it needs to go and fetch from the database. Now it's cached. The next time I hit it, if I keep going, so there are 4 pods. I have to do it 4 times because it's a round robin distribution. And now it didn't go to the database because it's cached, it hasn't changed. Since all the requests should go through the REST interface, we know which entities are being created, which ones are being updated, and if there's any change in the database that doesn't go through the web interface, we can use something like Debezium or any other technology that does change data capture to then notify us so that we can clear the cache, update the cache, do something with that information. Okay, that's the first one goes to the database. Second one didn't go to the database. Let's see, we select all of them. 1, 2, 3, 4. That's ours. There you go. We do it 1, 2, 3, 4. Does it again. If we select with page 1 and limit 100, that's 1. That's 2, 3, 4. That's ours. So now you can see that it did the select. And now I'm going to show you the part where we build the infrastructure. Okay, so I have a script. So this is a script that I had to choose which cloud to use it. I happen to have a credit for Azure, so I used Azure, but you can do the same thing with CLI for any other cloud, so you don't have to decide which cloud. You can do the same thing with another cloud. The Terraform files need to change, but this script goes into your subscription, your tenant. It builds storage to store the Terraform state. It builds a service principal, like a system user, and that system user is the one that is executing the Terraform in the pipeline. And then you also get, once you have that bootstrapped, little by little, I was getting permissions, building code repositories, uploading the code. I did this little by little. Now it's a script that is probably 6,000 lines. You don't need all of it. If you have it already built, like the code repositories and everything, you shouldn't need the whole script. You only need to bootstrap Terraform, and then the Terraform can take over and do the rest, right? In this case, I also built a whole bunch of stuff. I built databases. I have a DNS zone because I have my own domain, so I have to connect everything. I have a key vault. Everything in the pipeline, whether it's a secret or not a secret, I treat everything as a secret, and it's in the vault because it's convenient. I don't have to think. If there's a variable, it goes in the key vault. Doesn't matter if it's secret or not. Everything is secret. So once you have that, what you get is basically something like this. What you get are your infrastructure project that has all the Terraform files inside. I build also 3 pipelines. Everything is done in the script, so you don't have to care about doing that manually yourself. Everything is created for you. So you have all the pipelines. For Terraform, I have 3 pipelines. One is a pipeline to check that whenever you make a PR, the thing is verified, it's valid. The one for build actually performs the apply of the Terraform. And then I also have one that I use to delete everything. Right now I just go there and take the resource group, delete the whole resource group, and that's that. So I don't have to run the pipeline to delete stuff. But you could just run this pipeline and everything would be deleted. The next thing is the base project, right? The base project, I come here, as you can see, you have the main artifact that produces 2 jars. The first one is the artifact, the other one is the jar with the sources. Then you have tests, those are the testing facilities, and then the sources for the tests. In this project, the important thing is that I'm defining basic specs. You can add or remove, and you can do whatever you want with this. In my case, I'm saying, look, the shape of any entity must have a field ID. That is a string. In my case, I'm using UUIDs, so this serves the purpose of laying the ground. If you have a nice base, then building the whole project is easier. That's why you don't start with even DevOps. You don't start with reliability engineering. You start with creating an environment where you can make the changes easily, and it translates to something that you're going to do in production. So this is just an interface. Then I have a contract. In my case, I'm just testing a CRUD microservice. This is just an interface that says, look, there are 4 operations. It has no implementation. I don't mention anything about persistence. There's no web anything here. Another type of entity is one that has, on top of the ID, it also has a version. And this version is of type long. And then for testing, of course, I have a base implementation, but this is just to show how it would be implemented in the most basic way. For testing, I have usually 2 or 3 classes here. The first one is the essence of the test. So I already know that something that conforms to my spec should behave in this way. So in the test, I do, okay, so this is the gist of the test, the essence. This is what I want to test. I want to test constructors. I want to test that you can get and set an ID, the hash code, the equals, and the toString. Those are the tests. In your project, once you depend on this, you don't have to, if you deviate from the spec, you can also show that in your tests by deviating from the basic test, right? And it makes it simpler. You deviate in one place, the test should deviate in one place. There's a parity with between the code you write and the tests you write. And since I have an implementation, a basic implementation, then I also have a basic implementation of the test. I'm building a library that someone else will use. I want to use my library in the way I think they will use it. In this case, I'm extending from the essence, from the gist of the test, and I'm saying, okay, I'm testing this type of object. I provide a few things, how to create UUIDs and so on. And then what I do is, all right, if I have something, I'm gonna try to convert the UUID and going back, and these tests are just to test some of the converters I have here. The idea is this test runs every one of the tests in the gist, and on top of that, I run a few just to test that the converters are working and everything is okay. Once this is done, you get 4 artifacts. These artifacts are here. You have your main artifact, the tests, the sources for the main artifact, and the sources for the tests. For my pipeline, the pipeline is very, very simple. So once you run your pipeline, I just run the build, tests, and everything is done with deploy. If all the tests pass, there should be no problem with deploying this. And if you can see here, for example, you have all the tests are passing and the coverage is also at 100%. So now my base library is done, everything is tested, and the coverage is 100%. The most important thing always with testing is branches. The branches are your use cases. I don't care about instructions, lines of code, I don't care about that. I care about branches. In this case, nothing is missed, everything is tested. All right, that's the first project. The second project that I showed was JPA. This is done in a similar way. You get 4 jars, you get your JPA main artifact, the tests, sources, and sources for the tests. In this case, what I'm doing here is saying, okay, if you have something that conforms to the core, to the spec, then you should have something that is an entity that conforms also to that spec, right? And here I'm implementing the spec that I defined. So this is API first, but usually when people hear API first, they think, okay, code generation. No, you can define your spec in the same code, in the same language that you're going to run your application. It's no different than writing in one language and then generating the code. I'm just skipping one step. All right, so if I have entities that conform to that spec, then these entities have this property. And I also have the other one that has also the version. If you see, I'm not declaring the ID here, even though this is also conforming to the other spec. I'm already implementing something that extends from the other one. So in this case, I'm extending this and implementing the other one, so I get both in this. I get the ID and the version. And then that other contract in this world, in the persistence world, the contract is fulfilled like this. So this is implementing a contract to persist with the 4 operations, right? So you have create, retrieve, update, delete, CRUD. For testing, you have here we have 3. In the other one we had 2. In this case we have a template that has basic implementations of the tests. So you test how to create, you test how to edit, and so on. This is an abstract class. This has just the implementation. The gist of the test builds the world and tests your implementation. In this case, I'm doing the weld setup to have all my beans and everything for injection, everything ready for injection with the scopes that you want, everything that you want, and that's the idea. In this case, I'm injecting a mock entity manager that when you come here, this method to get the entity manager is abstract. That's something that you provide. I don't know what server you're going to use. I don't know how you get your entity managers. You provide one entity manager, and then this will take care of all the logic of persisting, retrieving, updating, and deleting your entities. All right, so we have the gist. In this case, the gist uses a mock entity manager, and once you inject it, it'll do everything that you have it set up to do. So in this case, I don't have the entity manager here, but I do have it. Get entity manager. Where is the entity manager? It is here. You see? So this is the mock entity manager. The same way I tested how the people using this library are going to use the tests, I do the same here. I say, okay, I'm going to test this implementation, and this is one of the good thing is that once you implement a test, if you don't deviate from the spec, this is how your tests look. Empty. You're saying, hey, test this against the spec. And it'll run all the tests that are here and make sure that this passes the spec. For the gist, you don't need to do anything else. So you still have to clean up this, but if you see, everything in this place is empty because it's just using the base thing. Once you deviate, you're gonna clearly see that you're deviating because the test is not empty. For the version, it's the same thing. So let's see this. This one extends through the template, and the template is here. I'm creating a default implementation of my facade, a default implementation for one of the identifiables, and I provide this. All of these tests are then ran against that to make sure that I can generate utilities for people to use in testing, and I know how to use them myself so that I can write good documentation and tell them how to use it. For web, it's almost exactly the same as for JPA, but in this case, you have six artifacts. And why six? Your main artifact, sources, testing utilities, sources for testing utilities. But I have a third artifact that is the client. This client is something that is going to be public. So once you create your microservice, you're going to have a client that you can give others that will consume your service. So they don't have to do anything. They just insert that and they will be able to consume your service because it conforms to the spec. If you change or deviate from the spec, you're going to have to change the client to conform to your new spec. All right, so I have the service here. What I have here is an interface that has these create, edit, find all, remove. And then I have an abstract REST endpoint that implements that interface, right? I have other few like facilities. For example, I created this annotation to compress things, and whenever you put that annotation anywhere, it'll just check if the calling client is able to support gzip, and if it does, you gzip. Some servers already have this built in, but I just wanted to show you that you can put all of that into a supporting library and still be able to use it. Okay, and for the tests, they are almost exactly the same as for, so this is testing the gzip, this is testing the other stuff. I don't test annotation because there's no code, so those are ignored. The same thing, you have template, it's an abstract class, you have the gist that extends the template, and then you have this endpoint test that also extends the template. So this is for testing internally, and the gist is to give to someone else to test externally. What I'm doing here is almost exactly the same. I'm just building the world. As you can see, there's no implementation. I'm just saying there's something that conforms to this spec, to this facade contract, and you can mock it because I know how it behaves. Once you come here, you set up the world. In this case, what I'm doing is setting stuff for injecting configuration from the outside, and the idea is if you have a bean for this, then you can mock it, and if I have a bean for this, you can mock it as well. Why? Because the abstract one has something that is injected here, right? That will conform to that specification. So to test it, I just say, okay, assume there's something like this that in the real implemented microservice will be provided. Once you test it, you do this. And just by extending these gists, you can get to a place that looks like this. So those are the three. I also have the Eclipse link. There's archetypes for everything. In this case, I created these four with archetypes. So you can have starter code that already works. I'm gonna explain these because these are the simplest ones. So these are the connectors for each database. For Oracle, what it does, it's just saying, look, just package everything that you see here. In this case, you have versioned Liquibase configuration files, so that if you're using Oracle, you just keep adding to this, and you'll find that from the deployment, I read this, build all the Liquibase config maps, and I deploy them to the Kubernetes cluster. Same for system, and everything is versioned. So you just need, you have a new version, create a new directory here, put the version that you want, and you're done. The same for the other connector, and this is the microservice. Here I'm using a reduced hexagonal architecture, like the original hexagonal architecture, which is called BCE. It's boundary control entity. In the boundary, these are your hexagonal ports, imports, outports. In this case, we only have imports, and this is the endpoint. So this is how an endpoint would look like using all these libraries. Since they all implement that contract, then I say, look, this is an endpoint. This has CRUD operations. This would be akin to the stereotypes in spraying or something like that. I just have to tell it, look, this performs the CRUD operations on this entity. You don't have to do anything else. For the, that's the B, that's the boundary. For the control, what I'm saying is, look, this conforms to that contract, and it uses this type of object, and this is where you provide the entity manager. The entity manager is just injected from configuration, and this configuration comes from one of the two projects, either Azure SQL or Oracle. And then you have your entity. You just need, in theory, if you see how empty these are, you just need to define your domain. I'm doing, like, this is overkill. You don't need all of these. You just basically need this to be an entity, the inheritance, the attribute override, if you want to change the name of the ID field, of the ID column, the table, and you don't even need this. You can put this outside in XML. What I'm doing is defining my 4 columns. If you notice, I'm not defining the ID because that's in the spec. I'm not defining version because this one doesn't conform to that spec. So this one doesn't have a version. And when you test, you can easily say, look, for my entity, these are the things. On top of testing the spec, I have 4 new things that I need to test. So I only test the new things that I add on top of the language, on top of the spec in the core. So these are my 4 tests. Maybe the hash code and the string change, so that's why I'm not using the one in the spec, as you can see. For the boundary, I have this test. It says, look, extend that one. These are the things that you need to provide. You need to tell me what's the type of the entity, what's the type of the endpoint, how to create one of your entities, like give me an example of one of your entities, and how to get an endpoint. In this case, I'm just injecting an endpoint, and you get that here. You also can put integration tests here. And this is going to be really useful when you deploy. In this case, I'm just creating a client and a target. I'm just running a few tests. I'm saying, look, give me all of the entities that you have right now. I perform some tests. At the end, I look at all the entities and make sure that the start and the end are the same. In the middle, I just create an entity. I try to find that newly created entity. I update it. I try to find the updated one. I try to delete it. Then I try to verify that I cannot find it if I look for it. And as I said at the beginning and the end, I just check that what I started with is what I end up with. These are just the implementations of this, which is like you can do this with Cucumber, you can do it with Gherkin language, and so on. I don't like having middlemen, so it's just straight from the test. In the control, it's the same thing. Since both the persistence and the web test similarly, just tell me how to create one of your entities and give me the facade for one of your entities. This is the facade for this test, and I'm saying, hey, you're gonna test this entity with this facade. All right, and when you get this, so you get 3 artifacts. The main artifact, you get the client, and you get the IT tests. Now I'm gonna show you the client. So the client is, I'm just saying, I have a client that does not deviate from the spec. It extends this one, and this is where you're going to find the endpoint for that microservice. Okay, so if you saw, I didn't implement anything. I just defined entities and provided examples of entities. For the deployment, this is where the magic happens. In this case, I'm going to show you the POM first, and I do the common denominator between your development environment and the cloud. In this case, for the technologies that we're using, is Maven. So I'm doing everything with Maven. If I have to test something, Surefire. Integration tests, failsafe. Do I have to launch a Docker container? The Docker plugin. If I had to look for code coverage, Jacobo. If I have to look for vulnerabilities, I use the vulnerabilities archetypes from OWASP, the plugin from OWASP. So this is what everything that you've seen produces naked artifacts. They depend on stuff that will be provided at the deployment, but they're not packaged with it. So when you come here, you need to tell me what you're deploying, what's the name of your artifact, and what version you want. In this case, I'm saying, look, take whatever version, the latest version you have, and let's deploy that. Okay? The service that you're deploying is this one. So this can even be parameterized, saying you can have the same deployment for multiple microservices. You just need to change the name of the artifact that you want to deploy. The version, you can keep it as latest, or you can specify as like a very narrow set of versions using this language. In this case is everything from 1.0 upwards. You can say, look, from 1.0 to 1.6, skip 1.7, and from 1.8 onwards, because maybe there's some incompatibility in 1.7 that you don't want to deploy. Okay, the deployment looks like this. This is where all the Lego pieces are gonna come together. So this one does have all these dependencies, but not provided. In the other projects, all of these dependencies say that they're provided somewhere. So you have core, you have the tests. You have JPA, you have the tests. In this case, I have Eclipse Link because I want to also test with Eclipse Link. You have web, you have the web client, and then you have the service, the definition you made in the service project, right? And that's something that gets put in here. And you have also the integration tests. These integration tests are used down here. So this is the Maven failsafe plugin, and I'm saying there are tests. Where do you find those tests? You find them here in the artifact for the service, but with a classifier of IT-tests. So it'll go into that artifact, look for any integration tests, and run them. These tests are run on containers. And what I do is I have a profile that has test the whole thing with Azure SQL or MS SQL. I have another one that has the same thing, test environment full with Oracle down here. This is Azure. So you can test your service with a database both in containers, or you can test your service in a container with a database in the cloud. And this profile does that. It doesn't launch the database container, it just goes straight and tests in the cloud. Right, that's one. And this is the one for Oracle. What does this do? It just says, okay, on top of the dependencies that you have in the main part, you're also going to depend on this persistence project, and you're going to use this driver. That's it. You add two more dependencies. You choose them at compile time. That's why in the diagram I showed, you could see that at compile time you could easily switch. All right, what does each of the profiles do? It takes everything you have, it overlays the different parts, and then it builds Docker containers. The images it builds is, first I launch this database. For Oracle, I launch an Oracle database. I launch 23 AI, I think. I launch Liquibase, and in this case, I'm saying, look, there's a folder called system that has a changelog inside. Run that. Then after launching that one, I launch this one, which is after the first one, check that you can run it again and nothing has changed. I do the same with the service, so system, service, and DDL. System is for creating users and passwords, security related stuff. Then service is for creating schemas and more like DDL is for creating tables and indexes and those kinds of things. And after you run all the 6 Liquibase containers, then I build the main service. This just takes your Docker file, whatever it is you built, I'm going to copy that, and since this is the only thing that changes, I put it at the end because you can benefit from caching all these layers in Docker. So if only the last layer changes, it's faster to build. Okay, so I built this. After that is built, the IT tests are run. If everything passes, then you have OWASP, you have other tests to see that you don't have vulnerabilities or security holes. And if I show you the pipeline, there's an extra step that I just added. That is, so I tested everything. In this case, I'm using Payara to test it, which is a server just like JBoss or OpenLiberty. It's just a container, right? I do everything, test everything. Since everything is standard, I don't have any proprietary annotations. I'm not really using any particular technology. There's no reason that, besides from deploying it in Payara, that I cannot deploy it using other technologies. For example, Spring, Micronaut, Helidon, Quarkus. So I said, okay, let me try Quarkus. Once you deploy, I'm going to generate the package, right? Here what I'm doing is the following. I'm pushing the Docker image that I just tested. I'm creating a new image just for Quarkus, where I put just my microservice inside. I build it and I push it. And if you can see, if you want to see how that's built, you can see that here. This has a lot of information, but the main thing is I have a staged build inside Docker. So whenever I build using this image, it will compile my artifact. So I'm saying, look, I'm gonna try to compile stuff that is in these folders, copy those, compile everything, and then package it as a static binary. So this takes everything you saw in that POM file from before, all the dependencies and everything, analyzes them, and then it just narrows everything down to the bare minimum. Once you have that, that's why you saw that my image had only 3 layers. These are the layers. It's basically copy my application, expose a port, run my application. This from scratch means there's nothing else. There's no Linux image or anything. There's no directories, there's no vulnerabilities because there's no other dependencies, only what you have inside. You see the pipeline for that. Then I also have scripts for generating Helm charts, and that's boring, to be honest. That's not something exciting. I mean, it's okay, I can show it, but it's not particularly important. You can build static Helm charts and deploy them yourself. I'm just building them dynamically because I have a dynamic set of config maps that come from the Liquibase folders for system, service, and DDL. And they're versioned, so I have to mount them as volumes and so on. So I just go there, read, build my volumes, put them in the correct Liquibase containers, and then I put at the end that's the only dynamic part, the Liquibase part. What I do here is, okay, this is building Yeah, this one is building this static binary. It's probably ends up here. Yeah, this is here. Then you go offline, meaning that other Docker file doesn't require network connectivity once it starts building. It's just downloads everything that it needs and then goes to work on those. Here you go. So, and these are the statistics for the build. So you have eight steps here, and it's parsing, it's doing tree shaking, pruning, doing a whole bunch of stuff, and finally, this is a very memory and CPU intensive process because it's looking at everything you can do in your application and saying, hey, this path that you're never going to take, that you're never taking, we can remove it. And it's starting to remove code, dead branches, and so on. In the end, what you get are the statistics for your project, how much you saved, and this is the final image. It's, in theory, it's 29 megs. And once you see the container registry, it is 29 megs. Once you download it, probably your local Docker installation might add stuff for telemetry and to be able to use it with Docker Desktop or Rancher or whatever. It builds this runner, it copies the runner, and that's your application. So 29 megs, that's your Docker image. It pushes everything to the repository. It takes the Helm chart, packages it, and pushes it to the repository so that you can take the exact same Helm chart and work with it. So you can go back in time and deploy. You don't have to run the deployment again to actually deploy a previous version. If you go to the container registry and I go to repositories, you see, these are my Helm charts. These are the Helm charts I have produced. Each one of them has a version, and I can take the version. My versioning scheme is simple. I just have major, minor, and then the date. In this case, these are the Helm, and these are the services using Payara. These are the services using the native image. So these are the ones that are 29 megs. These have almost nothing inside. If you compare it to the other one, you see that this one has a lot more layers because you have to install the Linux distribution, Java, then the server, libraries, and many more dependencies that you would have when you have a native image. And once you have everything there, then you can go and just deploy. The deployment doesn't really take a long time, 1 minute. And if nothing changes, it's probably seconds. Most of the time you spend transferring the Helm image. If I repeat this same run, it would take 6 or 7 seconds because the image is already there. Okay, so I take, let's say, 2 minutes for each environment, for each microservice. And what you get are these workloads. My Kubernetes cluster has the 4 environments inside, but the way I structure it, it makes sense because I'm using a different node pool for each environment. So you can have a single cluster, and for each environment you provide just a node pool. It's the same cluster for all of them, but they are physically separate. You don't need to really have multiple clusters unless you want geographic replication of the thing. Then you would have like a cluster in the US, a cluster in Europe, a cluster in Australia, a cluster in Japan. But for environments inside cluster, even for multi-tenancy, I would put just a different node pool and have a different namespace for that, because you can easily put policies in place to prevent cross communication. By default, anything in one node, anything in one namespace is not able to communicate to another namespace unless it knows exactly where it's going. And there's other stuff that the bootstrapping script does for Terraform. For example, it adds cert manager to have automatic certificate management, rotation, so on. I have external DNS, so whenever I deploy something, the ingresses get updated and my DNS gets updated with the new stuff. I can show you here. So have the ingresses. I have an ingress for each of the environments, and each one of them is associated with one or more domains. There's not a lot more to it. For ingresses, I'm using ingress nginx, but in the script, I can choose at the beginning, hey, I want ingress nginx, I want app routing, I want application gateways. You can choose, and it'll build different architectures or different resources just for each feature that you want. In this case, I like nginx, so I'm using nginx. This NVD API key is used to check for vulnerabilities in the National Vulnerability Database that is maintained. So every time you see a CV code, that's in that database. And that's it. That's everything. So what's the developer experience like? I mainly use 3 IDEs, VS Code, IDEA from IntelliJ, and NetBeans. And I'm gonna show you, actually, I'm gonna try to see. I was testing the service right now. So this is the service. The memory is at 197 megs flat. So this is something that is gonna help you with the density of your services in your Kubernetes cluster, because it helps you budget better. So you know that your basic service is less than 200 megs. So you put that and then the caching on top, whatever the shape of your object is, and you can more or less say, hey, I can, with this amount of RAM, I can cache this many thousand records. For the CPU, the highest it went was 0.1%, which in Kubernetes that would be like 100 millicores, which is great. I have my deployment set at start at 1 millicore and 65 megs and go like 2000 millicores and 16 gigs of RAM. It's never gonna go that high, but having that amount of having that density, the amount of containers you can put is much larger than deploying a traditional non-native application. All right, and for the developer experience, well, you get your projects. What I did was take my projects, deployed the not deployed. I compiled a version 1.0 snapshot just to have them locally, and I select my profile, Premiere. So in this case is SQL. There's Oracle. I'm gonna try SQL first, and what this does is generate the package, compile it, generate the package, Dockerize it, and then you're gonna see, actually, let me try to check if I can stop all of these before this fails. Going to, yeah, so let me wait for this to finish. Yeah, there you go. If I do it again, you're probably going to be able to see so this ran some tests for stuff that is in the deployment, but since everything else is outside and it's already tested, you don't need to test it again. Okay, so this is launching the database. It's this one. So you have the database, and now, oh, Liquibase. So it's launching Liquibase, and if you can see the logs, you're going to be able to see, for example, in this case, it ran 2, and that's it. The next one, we'll try to run it again, and it'll find that it was already run, previously run, and you can check that you can run it multiple times and the result is always the same. All right, so now it's launching, it launched all the Liquibase. Now it's launching your service, the one that you're testing. As soon as it finishes launching this, it'll look for all the integration tests. It'll launch the integration tests like so. It did all the steps: calling, checking the database, creating, retrieving, updating, deleting. And after that, it deleted all the pods. Now it's gonna be checking for, it's gonna generate the Helm chart first. So this is going to generate that Helm chart. And then it's going to look for vulnerabilities in the vulnerabilities database. Okay, I didn't put an NVD key. I have one for my domain, but I didn't put it here just to be able to show the code. All right, so you have that. It built success. Less than 2 minutes. Test it end to end. And when you go to the cloud, you can see that it doesn't take a lot to deploy. I mean, if you look at the whole thing, 15 minutes to do the whole build testing. It built it twice, built all the Helm charts, built everything. So this is what we did just now, 2 minutes 46 seconds. This one, building the deployment package, 11 minutes. This is the one that I was saying that is memory and CPU intensive, because this is building the native image, and it's also compressing. So that image is compressed. It uses UPX to compress your executable, and depending on your level of compression, the level of compression you want, it might take more or less time to do. So I put level 10 because, as you saw, whenever I launch one of these pods, it takes 110 milliseconds with level 10 compression. So I'm not terribly interested in launching my pods in 50 milliseconds. I might be interested in reducing this time of building, but 11 minutes is perfectly fine for me, and I deploy my microservices individually anyway, so these can run in parallel, and it's okay. Okay, and well, I hope you have comments. I hope this was helpful. What I'm going to do next is I'm gonna work on the performance. So I'm gonna put this script in each of the stages so that after each deployment, I get a performance baseline I can compare with the previous one and so on. And I didn't show a lot about the infrastructure, to be honest. So in this case, it's not too exciting. It's Terraform. The exciting part is that all this Terraform was created using a script. So the script created the Terraform. There are tools to do that. In my case, I just wanted to learn to use you can do this with any CLI for any cloud provider. It's helpful for me because I learn about one cloud, and also I wanted to check if a resource was there before trying to create it, and Terraform doesn't have a way to do that right now. So if it wasn't there, I'll just create the Terraform file. If it was there, what I'm going to do is import the state into my Terraform file instead of trying to create it. So I still create the Terraform file, but I just don't apply it. I just import the state. That got me thinking, maybe I can make a module that represents a microservice. And that module will create databases, will create pods, will create deployments, will create all sorts of things that represent. It will create repositories, it will create pipelines, service principals, other users, connections between the DevOps environment and the cloud. And then I can use something like Backstage, which is an internal developer portal, to just have everything with a nice UI where you can click a button and you get one microservice. You click the button again, you get another microservice. So that would be useful because you can also automate generating documentation. You can automate generating all sorts of things for compliance. For example, if you need documentation, you can automate that out of using that internal developer portal. All right, as I was saying, if you have comments, leave them below. If you want us to deep dive into something that I just showed, let me know. I'm more than happy to help. All right, happy coding.